Hi everyone, welcome to the Chemistry Learning channel. I'm very passionate about chemistry and excited to share this with you. If you like this video, like, subscribe, and share. This video, I'll be covering the foundations of chemistry, which are very important to understanding the life sciences and learning more about our physical universe. It's also useful in many subjects such as biology, biochemistry, engineering, physics, and so many more. In this specific video, I'll be covering what is matter, classification of matter, physical and chemical properties. So what is matter? Matter is anything that occupies space, contains mass, and is composed of atoms. It's basically everything that is around us. And examples, as you see, are the wooden cube, which is a solid, milk, which is a type of liquid, and a balloon, which is filled with gas. In this slide, I'll be talking about atoms and molecules. Atoms are the smallest building block of all matter. They consist of a nucleus, which includes subatomic particles such as protons and neutrons, and is surrounded by a cloud of electrons. The left image is of a helium atom. As you can see, its nucleus contains protons, which is positively charged and is surrounded by a negatively charged electron cloud, and its nucleus also contains a neutrally charged neutron. Molecules are multiple atoms joined together acting as a unit. The image on the right is a caffeine molecule. As you can see, it consists of a carbon, hydrogen, nitrogen, and oxygen atom, all bonded together, behaving as one molecule. Be talking about the classification of matter by state. The main three states are solid, liquid, and gases. Solids are rigid and have fixed volume, and the atoms are packed closely to each other and in fixed locations. For example, rock, wood, and metal. And then liquids have fixed volumes and take the shape of their container, and their atoms are packed as closely as they are in solids, but they are free to move relative to each other. For example, water, blood, milk. Gases do not have fixed volumes and expand to fill their containers, and they have a lot more space between the atoms. Gases are free to move and they're compressible. Examples include oxygen, hydrogen, and nitrogen. It shows how the atoms are positioned in solid, liquids, and gases. So, like I said before, the solid is more rigidly positioned. The atoms aren't as free to move. And then in liquid, they're a little less rigid. However, they take the volume of their container. And then in gases, the atoms are free to move and they also take up the shape of their container. In this slide, I'll be talking about the classification of matter by composition, and the two main types are pure substances and mixtures. But in this slide, I will only be covering pure substances, and in the future slide, I'll be covering mixtures. Pure substances consist of constant compositions, exactly the same makeup and physical properties like melting point and color, regardless of the source that it is isolated from. An example would be table sugar. And a type of pure substance are elements. Elements cannot be broken down into simpler substances by chemical changes, and compounds are another type which can be broken down by chemical changes. Some examples of elements are shown on this slide. As you can see, anything from the periodic table of elements is a pure substance and a type of element. And then, so to the right, I have a few examples of elements from the periodic table: magnesium, lithium, fluorine, aluminum. In this slide, I have some examples of compounds. As you can see, the first one is water, which has 2 hydrogens and 1 oxygen to form H2O, which is water. And then another example would be NaCl, which is table salt. As you can see, it contains Na and a Cl. So these are both types of compounds, table salt and water. In this slide, I'll be talking about the classification of matter by composition, specifically mixtures. And the 2 types of mixtures are homogeneous and heterogeneous. So a mixture is composed of 2 or more types of matter in varying proportions and can be separated by physical changes such as evaporation. And the first type is a homogeneous mixture, which can also be called a solution if it's liquid. And then this mixture contains the same composition throughout and is uniformly mixed. An example would be a sports drink. And then a heterogeneous mixture is one that has varying compositions and is a combination of 2 or more that are not uniformly mixed. Examples would be chocolate chip cookies, chicken noodle soup, and salad, because each bite is different. So an example of a homogeneous mixture is also tea with water and sugar that is well stirred and dissolved, because with each sip you have the same flavor profile, which means that the drink, the solution, is well mixed and dissolved and is the same. And then for a heterogeneous mixture, we have a salad, which has different components and is non-uniform throughout. For example, with one bite, you could get lettuce and a crouton. With another bite, you could get lettuce and a tomato. I'll be talking about physical and chemical properties. Physical properties are properties not associated with a change in chemical composition. Examples include density, color, hardness, melting and boiling points, and electrical properties. Physical changes occur when there's a change in the state of matter. For example, when sugar dissolves in water in coffee, or when steam condenses into liquid water because it's going from a gas to a liquid. And then chemical properties are properties associated with the change of one matter into another type. Examples are flammability, toxicity, acidity, heat of combustion. Chemical changes occur when there's more than one type of matter produced, and that is different from the matter present before the change. Examples include the formation of rust or food being cooked, because we are creating a completely new product. Like when there's rust, the metal reacts with oxygen to form a completely different product. Thank you for watching, and I hope you'll like this video.